Okay, dear student, let us see what is there in this question. An experiment. In an experiment, a beam of electrons with energy 440 mega electron volt are incident on oxygen-16 nuclei. The variation with the scattering angle of the relative intensity of the scattered electrons is shown. Okay, so relative intensity of the scattered electron is this, and the graph is shown here. Clearly, it is having a dip here, and this dip is occurring at 46 46 degrees. Okay, now after this, identify the property of the electrons demonstrated by this experiment. Okay, so first of all, there is an experiment which is Davison-Germer experiment. These kind of graphs and these kind of things, they relate to Davison-Germer experiment. So Davison-Germer experiment was about the wave properties of electrons, like of the particles. So I think in 1921-22, Louis D. Broglie gave the theory that electrons have a wavelength. And in 1925 itself, the experiment by Davison-Germer was done. And in that experiment, they took electron beam and they took the nickel crystal. The electron beam was hitting the nickel crystal and then they were getting reflected. So there were two beams which were created and they were creating interference with each other. So this was similar graph that was that was achieved there, and so they established the wave nature of particles. Wave nature of particles, yes, the wave nature of electrons, and this experiment is related with that. Now the kinetic energy is given as 440 mega electron volt, and oxygen atom is also there. So now we know that the angle is given like this. So the first question is identify the property of the electrons demonstrated by this experiment. So clearly it is the wave properties of electrons or the matter. Show that the energy E of each electron in the beam is 7 into 10 to the power negative 11 joule. That can be easily done because the kinetic energy is given as 440 mega electron volt. This can be converted into joule very easily, like 440 into mega electron volt can be converted into joule by using this. So that will be the correct answer. And if I use my calculator, I can say that yes, the answer will be yes, it is exactly coming out to be this. So this is how we do this. Let us see the mark scheme and see if like what is the answer given in A. So A1 is talking about the wave properties, exactly the thing that I was telling. And then A2, yes, they have also done the same thing, 440 mega electron volt, and which is 7 into 10 power negative 11 joule. So these two questions are now over. Let us move to the next question and see what they are asking here. The Lewis de Broglie wavelength. Okay, the de Broglie wavelength of an electron is given by Hc by E. Show that the diameter of the oxygen nucleus is about 4 Fermi meter. Okay, so we want to find the diameter of the oxygen. So this we have done in topic 12.2, and there was a topic estimation of the nuclear size. So we did three things in that. Point number one, we did impact parameters. Sorry, distance of closest approach, which was done in regards to Rutherford's theory, and we found the distance of closest approach, and from there we estimated the size of the nucleus. The second experiment, the second thing that we can do is when we talked about the radius of the nucleus, and we found this to be the formula that the volume of the nucleus will be directly proportional to the mass number of the nucleus. This was the second method. The third method, which is used for the estimation of the diameter of a nucleus, that is with the help of interference or diffraction. And the formula used is sine theta is equal to lambda divided by d. So this is what is the formula that we use, where d is the diameter of the nucleus, and we will apply this formula here, and we'll try to find the diameter of the nucleus. Uh, so the wavelength is given by Hc by E, the formula is there, and E we have already found in joules. That is kind of 7 into 10 power negative 11. So H and C will be having some value, E will be having some certain value. This is wavelength. So theta is 46. So according to me, it will be like this, lambda divided by D. Accordingly, D can be written as lambda, which is hc divided by E, and sine 46 will go into the denominator. I think this is the diameter of the uh, oxygen 16 according to the data. This should be the answer. We will see in the go to the mark scheme. I'm not going to calculate it now. Let's see if they have done the same thing. Okay, so first of all, this is hc divided by energy E. So they found the wavelength, exactly the same thing, and the angle is 46 degrees, and they did exactly same whatever I was telling you, and accordingly we will find the diameter of the nucleus. So this is the method which you have to employ. By the way, this method, like in this formula, sine theta is equal to lambda by D, you might feel that it is similar to the formulas that you have used in the case of interference or in the case of diffraction. This thing is actually the same thing. So it's not like the formula is the same, but it is the same. Okay, it is the same thing. And according to that, we find the diameter of the nucleus. Yes. Now we're moving into the next question. Let's see. Estimate using the result in A3 the volume of tin nucleus. State your answers to appropriate number of significant figures. Okay. So now we have to use the second method that I have suggested you, that that R is equal to R naught A raised to power 1 by 3. This is the formula that we are now going to use. How do we derive it? The volume of the nucleus, that is 4 by 3 pi r cube, is directly proportional to the atomic mass number, and accordingly we can say that the radius of the nucleus will be directly proportional to cube root of the mass number, and so R2 divided by R1 is equal to A2 divided by A1 raised to power 1 by 3. You can go for this formula or this, it is actually the same thing. This formula is derived from this uh, proportionality only. R naught is the constant of proportionality which has a form value 1.2 Fermi meter. Okay, so in this question there is a catch here. I know, because like I did this question sometime earlier when I was teaching. Let me tell you that also, and let us use the other thing also. Now, they say, according to the question, estimate the volume of tin using the result in A3. That is very important. Now, what is A3? Let's go for A3. Yeah, this one. And we found that the size of the oxygen is coming out to be 4 Fermi meter. So we will just assume it to be 4 Fermi meter, whether it is or whether it is not actually. But the question says it is, we will just assume it to be 4 Fermi meter. So I am going to use R of 10 divided by the R of oxygen is equal to the atomic mass number. No. We do not want to use the, yeah, we can use the atomic mass number here. Just a moment. R is equal to R naught. That we will not be finding. Yeah, let us go for this. So this will be the mass number of oxygen. This is mass number of 10, and then it is 1 by 3. Let us find this. So the radius of oxygen is 2 Fermi meter. Multiply by this. The mass number of tin is given as 118. Mass number of oxygen is given as 16. Isn't it? Yes. It's not the isotope or something. It is 16 only. And it will be 1 by 3. This will be our answer. And accordingly, just a moment. My answer is coming out to be 3.89 Fermi meter, which can be approximated as 3.9 Fermi meter. Okay, but the question is asking you to find the volume. So volume can be taken as 4 by 3 pi r cube. So it will be 4 by 3 pi 3.9 into 10 raised to the power negative 15 cube. And we will see what is this value now. So 4 by 3 into pi into 3.9 cube. Yes, I'm getting 248.47 into 10 raised to power negative 45. Accordingly, I can say that it is 2.5 into 10 raised to power negative 43 because two zeros have been used. So this will be the volume meter cube. This should be the correct answer for us. So let us see. There is a catch in this question also. I will let you know it later. Let's see what is the answer given in the mark scheme. Yes, here. Okay. Yes, the answer is 2.5 into 10 raised to power negative 43. Exactly the same thing. And answer is only supposed to be up to two significant figures. So the answer will be 2.5. Otherwise, it is coming out to be 2.48 or something. So the answer is 2.5, 10 to the power negative 43. They are also using the same method, by the way. Now, there is this alternative 2 also, but that is, now this is a problem here. What is the problem? You see, alternative 2, the answer is not the same here. You see, here the answer is 2.5, here the answer is 8.5, and let me tell you why. See, what we did, I told you that we would be using this formula, the radius of tin divided by the radius of oxygen, this. And according to the question, I took radius of the oxygen atom as 2 Fermi meter, but we don't know whether it is actually 2 Fermi meter or not, isn't it? It is given in the question, and they say that using the result in A3, so we just assume that the radius of the oxygen nuclei is 2 Fermi meter. But now let us do one more calculation. Now R is equal to R naught A raised to power 1 by 3. This is also another formula that is derived from the same proportionality, but the value of R naught is found to be 1.2 Fermi meter. Now if I use this here for the tin, so the radius of the tin will be 1.2 Fermi, and this will be 118 raised to power 1 by 3. What is the value that I'm getting now? Let's see. 1.2 into 118 raised to power 1 by 3. So I am getting the value as 5.88 into 10 to the power negative 15. This is the radius of the tin nuclei. So what will be the volume? 4 by 3 pi r cube. So my into 4. Yes, I am getting the answer as 854 10 raised to the power negative 45 meter cube, which is coming out to be 8.54 into 10 raised to the power negative 43. Now, what is the problem? You see, the answer that I was getting from this method, it was different, but the answer that I am getting from this method, it is different. From this I was getting something 2.5 into 10 is 43. Here I am getting the value as 8.54, which is correct. This is given as alternating 1 and this is given in the alternative 2, but the answer is different. Now, if we are using this method, the answer will be 8.54. If we are using this method, it is 2.5. And why is that? Because this method is actually scientifically proven to be correct. So your answer should be 8.54. But because they are saying that estimate the volume of tin using the result in A3, which is that the radius of the oxygen molecule is 4 Fermi, diameter is 4 Fermi meter, which is actually not right, because the formula that you are using to estimate the radius or the diameter of the nucleus is not exact. The formula that will be used, that was used by Davis and Germer, like sine theta is equal to lambda by b, is not the exact formulation to find the diameter. Obviously you were getting approximate values but not the correct one. So according to that you are getting the volume to be 2.5, but actually the volume is coming out to be 8.54. So this is actually the correct volume in the real nature, but this is what should be the correct answer according to the question, because it is specifically written here that you have to use the data given in A3. So there is no discrepancy now. So this method is actually not supposed to be used. Although this method is better, this method is right, but we are not supposed to use it. So according to me, this answer should be correct. That is why in the mark scheme you have two different solutions, and both of them are having different answers. Okay, dear students, so that's it. This will be the last question for this question paper. Thanks for watching all the videos. Please share the videos with all your friends. Thanks for joining. All the best. Bye.